Welcome to 6.7, story problems. That's what we want. So basically what we have here in this setup, this is important. You're going to set up a 90-degree right triangle, and these are your angle variables, and then the lowercase letters are your side lengths, and the capital letters are the corners. Okay, so we're going to set this up on each problem, and then we're just going to go through our SohCahToa stuff. So get your calculators ready and your scientific calculators, because you're probably going to need them. So let's go ahead and get started. Given the indicated parts of a triangle ABC with lambda, I guess, is 90 degrees. That would be the 90-degree angle there. Find the exact values of the remaining parts. So alpha is 30 and B is 20. So now we got to get the other parts. We use SohCahToa, and we have 30 there, so that's a 30-degree angle on your unit circle. You should be able to know what those things are. So if I do, if I want to get A and I have B, that's my opposite leg and my adjacent leg, so that's tangent. So we're going to do the tangent of 30 degrees equals A over B. All right, multiplied by 20. What is the tangent of 30? Tangent of 30 degrees is your y leg over your x leg. So the short leg over long leg, that's 1 over the square root of 3. 1/2 over square root of 3 over 2. So this answer would be 20 over the square root of 3. We multiply it out, and we get 20 square root of 3 over 3 for A. Okay, so right now, we're just going to leave this as 20 over the square root of 3. And let's find out what C is. Well, I guess we could do B, or Bravo. What is alpha, beta, I guess, beta, whatever we call it, okay? So this is going to be 60 degrees, so we were supposed to figure that out as well. So that's the easy one. So let's use the alpha side again, and this time we'll do it in red. And we'll use everything we've been given. Try not to use the ones you've found. So let's not use that value. So we want C, that is our hypotenuse, and we'll use our adjacent leg. So adjacent and hypotenuse is going to be cosine. So SohCahToa. So the cosine of 30 degrees is equal to the adjacent leg over the hypotenuse C. Okay, so we multiply by C, and then we'll divide by the cosine. So C equals 20 over the cosine of 30. And what is the cosine of 30 degrees? The x value at 30 degrees is the long leg. So that's 20 over the square root of 3 over 2. Okay, so that would be 20 times 2 over the square root of 3, or 40 over the square root of 3. Okay, and what is that? You have to rationalize it. So 40 over the square root of 3 times the square root of 3 over square root of 3, and you get 40 square root of 3 over 3. All right, so those are your actual answers for A and C and Bravo. Okay, beta, sorry. Okay, now let's go on to number 2, and we'll go a little faster. So you're just using SohCahToa, so you see if you can do this. So beta is 45 degrees, which means alpha is 45 degrees as well. So now we can use either one of these. These are 45-degree angles, and you know what the 45-degree angles are. B is 35. So I'll do A again. And we do A. So A is going to be A over, this is the opposite leg over the adjacent leg. So tangent again. So the tangent of 45 degrees is equal to A over 35. Now the tangent of 45 degrees is 1. So that makes this really easy. So A is 35, which you should have known that in a 45-degree triangle, the legs are the same. And then to do C, you can do the Pythagorean theorem, or you can just set up another, let's do the sine. The sine of 45 degrees is equal to the opposite leg, 35, over the hypotenuse, C. So multiply by C, and then divide, and you get 35 divided by whatever the sine of 45 is, which everybody knows that's the square root of 2 over 2. So that's 35 times 2 over the square root of 2, or 70 over the square root of 2. And you rationalize that. I'll put it up here. 70 over the square root of 2 times the square root of 2 over 2. And that's 70 square root of 2 over 2, or 35 square root of 2. That's C. Okay. All right, as far as the answers are concerned, they are to be in exact value form. So what I have here, so that's A, this is C in the first one, A is that, and A, capital A is that, and C is this one up here. Okay, so we're going to keep using our unit circle values until we can't anymore, and then you'll use your calculators. All right, let's get at it. So again, number 3, we're at 45 degrees here, which makes this 45 degrees, and A and B are the same. C is 30. So now how do we get A and B? So since they're the same, we can use our trig functions, or you could use the Pythagorean theorem. I'm going to use the trig functions, and so should you, because you're going to get really good at them if you do. So if I want opposite over hypotenuse, that's sine. So the sine of 45 is equal to A over 30, or 30 times the square root of 2 over 2. All right, so 30 square root of 2 over 2 is going to be 15 square root of 2. And that's both A and B because they're the same. All right, and now we go on. Number 4, alpha is 60 degrees. C is 6. Okay, so again, B, or beta, is 30 degrees. So we're going to use 60 because that's what we were given. Opposite over hypotenuse, so that's going to be the sine of 60 degrees equals A over 6, or 6 times sine of 60 degrees, the y value is square root of 3 over 2. And that's equal to A, or 3 square root of 3. That's A. Now how do we get B? By doing the adjacent leg over the hypotenuse. Again, using only what we've been given, not what we found. So that would be the cosine of 60 degrees equals B over 6, or 6 times the cosine of 60. The x value at 60 degrees is 1/2. So that answer is 3. So those are your values, plus the degree we found. Moving on. Number 5, A equals 5, B equals 5. Okay, so since those are the same, that means these are 45 degrees. Okay, so we found those. Now to get C, again, I'm going to use trig functions. I'll use the opposite over hypotenuse, so the sine of 45 degrees is 5 over C, multiplied by C, and then divide by C, or divide by sine of 45. So 5 divided by the square root of 2 over 2, which is 5 times 2 over the square root of 2, or 10 over the square root of 2. We rationalize, and we get 10 square root of 2 over 2, or 5 square root of 2. That's C. And we have all those other values. Number 6, A is 4 square root of 3. C is 8. Okay, so now we don't have alpha. So let's use the opposite leg over the hypotenuse. So we get the sine of alpha equals 4 square root of 3 over 8, which is the square root of 3 over 2. So where is the y value, the long leg? Well, that would be 60 degrees. So alpha is 60 degrees. You don't need a calculator because you guys are brilliant. If that's 60, then beta is 30. Number 7, B is 5 square root of 3. C is 10 square root of 3. Again, we don't know anything, so we're going to use our sine function. You could go to beta and use cosine, do A over C. So let's just do sine of alpha is equal to 5 square root of 3 over 10 square root of 3, which is 1/2. Where is the y value 1/2? At 30 degrees. And that means beta is 60 degrees. All right, and number 8, B is 7 square root of 2. C is 14. Again, I'm just going to use alpha as the adjacent leg and the hypotenuse. So the cosine of alpha is equal to 7 square root of 2 over 14, which is square root of 2 over 2. Okay, so where's the x value? Square root of 2 over 2, that's 45 degrees. So alpha and beta are 45 degrees. Okay, well, what is A then? Well, A and B, if those are 45, then A and B are the same. So A is equal to 7 square root of 2. Number 9, given the indicated parts of the triangle ABC, approximate the remaining parts. So now we will use our calculator. So whenever it says approximate, that doesn't mean guess. It means get your calculator and you're going to round your answers. So alpha is 37 degrees. What's beta? So you take 90 minus 37. Why is it 90, not 180? Because they all have 90 degrees there. 180 minus 90 is 90 degrees left to be used between the two. So 90 minus 37 is 53. So that's 53 degrees. All right, so we got part of it. B is 24. Now let's solve for everything else. Let's start with alpha, and we'll use our adjacent leg and to get our hypotenuse. So the sine, this would be cosine for adjacent leg. Cosine of 37 is equal to the adjacent leg over the hypotenuse. Multiply by C, and then divide the 24 by the cosine of 37. So put that in your calculator. 24 divided by cosine of 37. And so this should be 30. All right. It doesn't say how far to go, so 30.1, I guess. And that makes sense. The numbers should look like the other numbers, or what you think they should be. Now we'll use opposite and adjacent. So that's tangent. The tangent of 37 is equal to A over B, 24. So multiply by 24 and take 24 times the tangent of 37, and you get 18.1. So A is 18.1. So lots of different answers there you're supposed to get. There's beta, and then your C and your A that you had to get. Number 10, beta is 64 degrees and 20 minutes. So divide that by 60 to get your decimal. So that's 64 degrees, 60.3 degrees, 64.3 degrees, and the 3 is repeating, okay? So that is beta, so 64.33, all right? A is 20.1, and we need everything else. So take 90 minus the 64.3 repeating, and you get 25.6 repeating degrees. So I'm going to use beta because that's what was given, and I'll use the adjacent leg and the hypotenuse. So that's cosine again. The cosine of 64.3, okay, equals the adjacent leg over the hypotenuse. All right, and so you multiply by C and then divide. So C is equal to 20.1 divided by the cosine of 64.3 repeating. So 20.1 divided by the cosine of 64.3 repeating, and that's 46. So C equals 46.4. All right, and then now we'll use the adjacent leg and the opposite leg, so tangent. So let's do the tangent of 64.3 repeating equals the opposite leg over the adjacent leg. So we're going to take 20.1 times the tangent of 64.3 repeating, and we'll get 41.8. So there are all the values that you needed to get, okay? All right, so number 11, convert the 51 by dividing by 60. So 51 divided by 60 is 0.85. So this is 71.85 degrees. Subtract that from 90. So 90 minus 71.85 is 18.15 degrees. Okay, so we know B is 240. So now let's get A. So let's just use alpha and do opposite over adjacent. So we'll use the tangent of 18.15 equal to A over B. Okay, so we'll take 240 times the tangent of 18.15, yeah. So 240 times, hitting the wrong buttons on my calculator, 240 times the tangent of 18.15 degrees, and that gives me A equal to 78.7. Okay, And now we got to do C. So we will use the adjacent and the hypotenuse. So that's cosine. So the cosine of 18.15 is equal to the adjacent leg over the hypotenuse. Multiply both sides by C. So C is equal to 240 divided by whatever the cosine of 18.15 is. So 240 divided by the cosine of 18.15, and that's 252.6, which makes sense, okay, if you think about it. Okay, so now number 12, let's see here. Alpha is 31 and 10, so 10 divided by 60 is 0.16 repeating. So 31.16 repeating is alpha degrees. And so we take 90 minus 31.166666, and we get 0.83 repeating degrees. All right, so now let's get everything. A is 510, so we're going to do, let's do the opposite over hypotenuse. Let's get the hypotenuse. So sine of 31.16 repeating is equal to the opposite leg over the hypotenuse multiplied by C and then divide. So 510 divided by the sine of 31.16 repeating. So 510 divided by the sine of 31.16 repeating, that's 985.5. Okay, makes sense. If A is 510, C is 985. Now to get B, we'll do opposite over adjacent. So tangent, the tangent of 31.16 repeating is equal to the opposite over the adjacent B multiplied by B, which means we're taking 510 divided by the tangent of 31.16 repeating. So 510 divided by tangent 31.16 repeating. So B is 843.2. So there's all our values that we were supposed to be getting. Moving on. 13. A is 25. B is 45. You could use the Pythagorean theorem to get C, but let's go ahead and figure out what alpha is. Alpha, if we use what we've been given, the opposite and adjacent, that's tangent of alpha, is equal to the opposite over adjacent leg. So alpha is the inverse tangent of 25 over 45. So 25 divided by 45, and then we take, depending on which calculator you have to do the inverse tangent. Let me see here. That gives us 29.1 degrees. So take 90 minus that, 29.1, and you get 60.9 degrees for beta. And now we get C. Let's go ahead and do the opposite leg over the hypotenuse. Again, that's the cosine, or sine, the sine of alpha is equal to 25 over C, and alpha, remember, is 29.1. So multiplied by C, and we're going to get 25 divided by the sine of 29.1. So 25 divided by sine of that is equal to 51.4. So there's all your values we were supposed to be getting. All right, 14. A is 31, B is 9. So again, let's use tangent and get alpha. So the tangent of alpha is equal to 31 over 9. So alpha is the arctangent or inverse tangent of 31 over 9. So that is going to be, hold on a second, 73.8 degrees. So that's alpha. So 90 minus that 73.8, and you get 90 minus 73.8. 16.2. Oops. 16.2 degrees. And to get C, we'll do cosine this time. So do the adjacent and hypotenuse. So the cosine of 73.8 degrees, that's alpha, is equal to the adjacent leg over hypotenuse, multiplied by C, and then we will get 9 divided by the cosine, 73.8. So 9 divided by the cosine of 73.8, and that is 32.3. So that's alpha and C and beta. All right, 15. C is 5.8, B is 2.1. Okay, so we have, if we do alpha again, that's adjacent and hypotenuse. So we're going to do the sine of alpha is equal to, adjacent and hypotenuse would be cosine, sorry. Oops. So this should be cosine. Cosine of alpha is equal to the adjacent leg over the hypotenuse. So alpha is the arc cosine of 2.1 divided by 5.8. So 2.1 divided by 5.8, and then you take the arc cosine of that. So 2.1 divided by 5.8, and the arc cosine of that is 68.8 degrees. So 90 minus 68.8, and we get 21.2 degrees for beta. And now to get A, we'll go ahead and use opposite over adjacent, so that's tangent. So the tangent of 68.8 is equal to A over 2.1. So multiply by 2.1 on both sides, and you'll get your answer for A. So 2.1 times the tangent of 68.8, and that gives us 5.4 for A. Those are all your values. Okay, number 16. C is 0.68. A is 0.42. So if we start with alpha again, that's opposite over hypotenuse. That's the sine. So the sine of alpha is equal to 0.42 over 0.68. So alpha is the arc sine of 0.42 over 0.68. So we're going to take the arc sine of that, and we get 38.1 degrees for alpha. So 90 minus 31.8, and we get 58.2. So we get all of these values here. So now to get B, we will go ahead and do opposite over adjacent. So that's tangent. Tangent of 38.1 is equal to 0.42 over B. Multiply both sides by B. So B is 0.42 divided by the tangent of 38.1. So 0.42 divided by the tangent 38.1, which gives us 0.54. That's B. So there are all your answers that you need. Moving on to number 17. Given the indicated parts of a triangle ABC, 90-degree angle, to express the third part in terms of the first two. So we want to solve for B, and we're going to use alpha and C, the hypotenuse. So those three pieces would be the adjacent leg and hypotenuse. So that's the cosine of alpha is equal to the adjacent leg over hypotenuse. So what we're doing is solving for B. That's what that means. All right, so if we solve for B, we multiply times C. So B is equal to C times the cosine of alpha. So we look at 18, we're solving for B. Now what pieces do we have? We want beta and the hypotenuse. So what are all of those? That's the opposite leg to beta and the hypotenuse. That would be the sine. So the sine of beta is equal to the opposite leg over the hypotenuse multiplied by c. So b is equal to c times the sine of beta. Okay, same thing here. Now we can put this up here again so you have it. That's alpha, that's A, this is beta, this is A, B, and C, and little b is there. Now, we have A, beta, and B. So what positions are those? Opposite and adjacent, so that's tangent. Tangent of beta is equal to the opposite leg over the adjacent leg. We're supposed to solve for the adjacent leg, multiply by both sides by A, and then we'll divide off the tangent of beta. So B over the tangent of beta is what A is equal to. 19, again, A, B, C. Across from A is little a, across from B is little b, and across from C is little c. And this is alpha, and this is beta. Okay, B, A, and alpha. So that's opposite over adjacent, that's tangent. So the tangent of alpha is equal to A over B, and we're solving for A, so multiply by B. So A is equal to B times the tangent of alpha. 21, same thing, A, B, C, A, B, C, alpha, and beta. We have alpha, A, and hypotenuse. So that'd be the opposite leg over the hypotenuse, that's sine. So the sine of alpha is equal to A over C. We're solving for C. Multiply by C and then divide off the sine. So C is equal to A divided by the sine of alpha. 22. Go ahead and set it up. Okay, we're solving for C. We have C, A, and beta. So what is that? From beta, you have the adjacent leg and the hypotenuse. So that'd be cosine of beta is equal to the adjacent leg over hypotenuse. We're solving for C, so multiply by C and then divide off the cosine. So C is equal to A over the cosine of beta. 23. So again, if we need it, so we have B in our problem, C and A. Oh my. So we're going to write B in terms of A and C. Since we don't have any angles, we'll use the Pythagorean theorem. A squared plus B squared equals C squared. And we're solving for B. So we'll subtract A squared, C squared minus A squared, and then we'll take the square root. So B is equal to the square root of C squared minus A squared. It's not plus or minus because B is a distance, and B has to be positive. Same thing on 24, A, alpha, B, beta, and little b, little a, big C, little c. So we have little c, little b, little a. Again, same thing, A squared plus B squared is equal to C squared. And we're solving for C here, so C is equal to the square root of A squared plus B squared. All right. And to whet your appetite, let's just look at number 25. A person flying a kite holds the string 4 feet above the ground. All right, so here's your person. This is 4 feet. There's the kite. Okay, so this is 4 feet here. The string of the kite is taut and makes an angle of 60 degrees with the ground. Approximate the height of the kite above level ground if 500 feet of string is pulled out. 500 feet of string, that's a lot of string. All right, so how high is the kite? All right, so we're going to get H. We're actually going to set H to be just, this little section here. And then we'll add 4 to it when we're done. All right, so you have 60 degrees. What have you been given? The opposite leg is what we want. and we have the hypotenuse. So we've been given the degree, we're using the opposite leg and the hypotenuse. So that's sine. So the sine of 60 degrees is equal to h not b, over 500. Multiplied by 500. And what is the sine of 60 degrees? So the sine of 60 degrees is square root of 3 over 2. It's a long leg. So that'd be 250 square root of 3 plus 4 feet. Don't forget that. So now we need to use our calculator. That's the exact answer, by the way. So we do 250 times the square root of 3. And that gives us 433 plus 4, which is 437 feet. That's pretty high. Well, if you think about it, 60 degrees is pretty high. So really the picture should look like this. And if that's 500, this is roughly 430. That makes a little sense. All right, that's a little teaser for what's to come.